Hello, gentlemen. Hope you guys did well with the synthetic division and understand both long division and synthetic division and are ready to move on to complex numbers. This video is going to give you an introduction to complex numbers. We're going to look at what it means for two complex numbers to be equal. We're going to look at how to add and subtract complex numbers and finish up by looking at how to multiply complex numbers. Okay, but first we've got to define really what a complex number is, and to do that we need to understand this imaginary unit I. I is defined as the square root of -1, and that simply also means that I squared is equal to -1. So if I had something like this, get my pen, if I had the square root of -9, obviously you can't take the square root of a negative number, but I can think about this as square root of 9 times -1, and then we can think about this as, okay, -1 times the square root of 9. Well, this term right here is just simply I. That term is 3. So this is going to be equal to 3i. Okay, so hopefully you've seen that in the past. And we talk about complex numbers now. Let me get that out of the way. When we talk about complex numbers, we want to talk about a number in the form of a plus bi. Okay, and where a and b are both real numbers, and if b is equal to 0, then obviously I'm just left with a real number a. If we have b is not equal to 0, we have what we call an imaginary number. A is the real part of the number, b is the imaginary part, and we'll have a pure imaginary number if a is equal to 0. So a number, for example, 3i, that's a pure imaginary number. Okay. Now complex numbers, the set of complex numbers includes both the set of real numbers and the set of imaginary numbers. All right, so this is a larger group. These two are subsets of this group right here, complex numbers. Let's talk about some properties of complex numbers. Two complex numbers are equal if and only if basically their real parts are equal. So in this specific example, I have a plus bi and c plus di. If these two are going to be equal, then the real parts have to be equal and the imaginary parts have to be equal. Okay? When I'm looking at adding and subtracting complex numbers, really straightforward. I just want to add or subtract the real parts, okay, and add and subtract the imaginary parts, like that. Okay? And we'll do a couple examples of these right now. So if I had a situation where I had two complex numbers that are going to be equal, I look at the a plus 2, which is the real part of this number, and 4, which is the real part of that side, and they have to be equal. Remember, the real parts must be equal, so that tells me that a plus 2 has to be equal to 4, which means that a has to be equal to 2. And similarly, we have to have the imaginary parts must be equal to each other. So in this case, 2b minus 3 has to be equal to 7. And if we bring the 3 over, we get 2b is equal to 10, or b is equal to 5. Alright, so if I have two imaginary numbers such that they're equal to each other, set the imaginary parts equal, and set the real parts equal to each other. There's a possibility to get two equations with two unknowns. Not a big deal. If I had something like, x plus y, x plus y plus 2x minus y I is equal to 6i, like that, that would tell me that x plus y has to be equal to 0 and 2x minus y has to be equal to 6 because there's no real part over there. And then I just simply get two equations with two unknowns. Not a big deal. I'm still setting the real parts equal, I'm still setting the imaginary parts equal, and then I'm solving. Okay? Let's do some addition subtraction. Here I'm adding two complex numbers. I simply want to add the real parts, so 13 minus 5, and I want to add the imaginary parts. Negative 2 plus 6, and I get 8 plus 4i. Pretty straightforward. Another one, I'm going to subtract. So again, I want to subtract my real parts and subtract my imaginary parts. So 3 minus 6 plus 2 minus 13, negative 3 minus 11i. Let's do one a little more complicated. Right here it doesn't look like I have an imaginary number, but if you look at this term in particular, you should see that we do. Because this is the square root of negative 18, I can rewrite that as, I can rewrite that as the square root of 18 times I. Just get that negative 1 out of there. And I should also know that the square root of 18 is square root of 9 times 2, which is equal to 3 root 2. Okay? So I'm going to make use of those facts right now. Here's the first one. I pull out that negative sign, and there it is. That's my I, because square root of negative 1 is I. Now I'm going to simplify square root of 18, which is 3 root 2. And now I just have a simple subtraction problem. I'm going to subtract the real part, and I'm going to subtract the imaginary part. Note that these two are just going to cancel, and I'm going to be left with 4. Okay? Let's look at multiplying complex numbers. There's two different multiplications that we're going to talk about. Both A, B, C, D, and E are all real numbers. If I just want to have a multiple like 3 times A plus BI, I'm going to just distribute that to there and to there. Okay? Because you can see right there. So I have A times E plus B times E times I. Simple example. Here I'm going to distribute that 3 to the 2. I'm going to distribute that 3 to the 4. And I'm going to get 6 plus 12i. Okay? I can also multiply two complex numbers together, and then I'm just going to FOIL here. Here's what the result's going to be, but I'm just going to FOIL. If I FOIL, I want A times C, A times DI, BI times C, and BI times DI. So I'm going to FOIL, and we know how to FOIL. And so here's an example. If I do that, I get the 6 times the 2, I have the 6 times the negative 3, that's where those two terms are coming in. Okay, I get negative 2i times 2, that's the negative 4i, negative 2i times negative 3i gives me positive 6i squared. Remember that wherever I see I squared, I'm going to replace it with negative 1. Okay, and so if I do that, I get 12 minus 22i minus 6. And I get 6 minus 22i. Okay, again, just subtracting the real parts. There was only one imaginary part, so nothing to do with that. Here is some homework. I want you to pay attention to these examples. Look at them. Here are some practice problems. This video sort of was an introduction. And so, we looked at defining I is square root of negative 1. We looked at setting two complex numbers equal to each other. We looked at addition and subtraction of complex numbers, and we looked at scale and multiple of complex numbers, and then multiplying two complex numbers together. In the next video, we will start talking about complex conjugates and looking at division. Okay? Make sure you guys are practicing, and if you have any questions, just email me. Thanks, fellas. Have a good day.